Hi guys, how are you? क्या हाल चाल है भाई? How is everybody? So I'm very sorry. My 9:30 class, which was for 12th standard, ended a little late, and so I had to that was the reason I got a little late. I'm very sorry for that. Uh, when you're teaching something very interesting and everybody is participating, you just can't leave the session between. So that was the reason. Something was I was giving them homework. I will also give you guys also a homework. Okay, but please do remember that today's session is very important. In today's session, good morning guys. In today's session, what we would do is we will discuss about hardness of water, and then we'll play a quiz. Okay, it's not a Menti quiz. I'm very sorry for that. It's not a Menti quiz. We will play a quiz. We'll take some 20 questions and we'll try to solve it. I would want you guys to be as attentive as you have been. Answer all questions correctly, accurately, in the least possible time in the chat box. Okay? Chalo. Very, very good. And hello Ankit, hello VSG, hello Shivam, Ritesh, Shaiba. Shaiba, I have answered your hello Chinni. Okay, Shaiba, I have answered your mail. Please do check it. Okay, I've also already given. Okay, very nice. Thank you, Ritesh. Practice is more important. That is what everybody should believe in. And chalo, let's start today's session. And chalo, let's move ahead. Let's start with what is hard water. We have until now discussed what is properties of water. What is hard water? Hard water is also known as khara pani. Okay, hard water is something which does not give a good amount of lather with the soap. Okay, it does not give a good amount of lather with the soap. So soap, if lathers, lathers means it gives jhag. Okay, soap if lathers is known as jhag. Okay, we call that as jhag in Hindi. You see a lot of ads where there's a lot of foam, and you can call it the foam part of when you dissolve soap in water. So that is that jhag. For that to get created, water should not have hardness. Okay, water is hard in two ways. There can be temporary hardness and there can be permanent hardness. Temporary hardness is because of the bicarbonates of calcium and magnesium. Remember, it is because of the bicarbonates of calcium and magnesium. Permanent hardness is due to the sulfate and chloride of calcium and magnesium. Okay? Yes. Understood? Permanent hardness is due to the sulfate and chloride of calcium and magnesium. So why it is known as temporary hardness? It is known as temporary hardness because in olden days, if people had the only source of water which was hard water, they would boil it and hardness would be gone. If you just have to boil the water and hardness would be gone. Permanent hardness cannot be removed by boiling. It cannot be removed by boiling. You have to use certain chemical methods to remove permanent hardness. Temporary hardness can be removed by boiling. Removed by boiling. Okay? So let's move ahead. How do you remove temporary hardness? How do you remove temporary hardness? By boiling. Okay? So when you boil, correct, very good Ankit. So when you boil calcium bicarbonate, what will happen? So I am writing heat. You are boiling it. Okay, you have taken water which contains calcium carbonate. You boil this water. You will get a precipitate of CaCO3 and H2O and CO2 will be lost. Okay. H2O and CO2 will be lost. You will get a precipitate of CaCO3. So the hardness can be removed by boiling. If you boil it, whatever hardness is there, it is due to calcium bicarbonate, it will precipitate as calcium carbonate. Similarly, magnesium bicarbonate will get precipitated as MgCO3. PPT means precipitate. And the rest of the part is H2O, that will not cause any problem. Okay? That will not cause any problem. Understood? That will not cause any problem. So removal of temporary hardness is due by boiling. Removal of permanent hardness will require certain important methods. So by boiling. Okay? Understood? By boiling. So let me erase this part. It is written over here as well that it is removed by boiling. So it is easily removed by boiling and decomposes the insoluble bicarbonates into carbonates, which are also precipitated. Okay. There is something also known as Clark's process, in which what we do is we treat the sample of hard water with lime. Okay, slaked lime, calcium hydroxide. We treat it with lime, or you can call it slaked lime. This lime will react with calcium bicarbonate, will give CaCO3, which is insoluble. Similarly, magnesium bicarbonate will turn into calcium carbonate and magnesium hydroxide, both of which are insoluble. Magnesium hydroxide is insoluble. Magnesium hydroxide is used as milk of magnesia. Gelusil has milk of magnesia. Okay, so that is the reason we use Clark's process. Please do remember the name. Clark's process is the process through which we remove the temporary hardness by adding slaked lime. Clear? It's very, very simple. How do we remove permanent hardness? How do we remove permanent hardness? Permanent hardness is removed in certain number of ways, and permanent hardness will require 4 different ways of removal. There are 4 different ways of removing permanent hardness. The first one is you add washing soda. Washing soda is sodium carbonate. Washing soda is sodium carbonate. Yep, washing soda is sodium carbonate. You add sodium carbonate, you will get a precipitate of calcium carbonate. Understood? So it is just a double displacement reaction. Calcium carbonate reacts with sodium carbonate, goes through a double displacement reaction, we get calcium carbonate precipitate. The next one is lime soda process. Lime soda process is exactly like the previous one. Okay, so remember calcium chloride sulfate. We have chloride and sulfate as the one which is causing permanent hardness. We cannot boil and remove it because they do not decompose. They do not decompose. Okay. I know, dear. Okay, sodium carbonate. Yep. Chalo. Lime soda process. Lime soda process is where you take lime, slaked lime, react it with these compounds. Again, a double displacement reaction takes place, and which causes the precipitation of calcium. You can see calcium carbonate. Calcium chloride will also turn in. Calcium chloride will turn into calcium carbonate and magnesium carbonate. So this removes the permanent hardness. There is the next method. So slaked lime. So the second method is slaked lime per sodium carbonate. So the previous one, you can see that lime soda process means we use calcium hydroxide plus Na2CO3, a mixture of the first one and the lime process. Okay, first one and the lime process. So what will happen is that we calculate certain amount of slaked lime and sodium carbonate, add it, convert the bicarbonate into carbonate, convert the chloride into carbonate, convert the sulfate into carbonate. The next one is the permuted process. Okay, the next one is the permuted process. and the permuted process is this. So permuted is obtained by fusing sodium carbonate, china clay and silica. Okay, permuted is obtained by fusing sodium carbonate, china clay and silica, and it is usually sold in market as permuted. I don't know the certain brand names for it as well. However, this is a very straightforward process. Can you see this aluminosilicate? Can you see this compound? It contains a Si2O8 unit. This is known as a silicate. Okay. Hello Vedant. Okay, so this is known as silicate. Now from this silicate, sodium is lost. You can see this. So this is permuted. Okay, from this silicate, sodium is lost and the silicate binds with the calcium and the magnesium ion. Okay, and sodium binds with the sulfate or the chloride part. Understood? It is just a exchange of two different types of ion. So silicate exchanges calcium and magnesium for sodium. Okay, and it comes out in the soluble form. Clear? Why is everything multiple of 2? Where is... It depends on the structure, man. Depends on the structure. The last process is the Calgon process. Okay, the last process is the Calgon process, and Calgon is sodium hexametaphosphate. Okay, NaPO3 whole 6 is also represented as Na2Na4PO36, sodium hexametaphosphate. Now when sodium hexameta, it is also exchanging ions. The sodium ion which is present outside this one, this sodium ion is being exchanged for calcium. This sodium ion is exchanged for magnesium. So you can see that, yeah, I'm sorry, just a moment. With that sodium, it is this sodium which is being exchanged. It is this sodium which is being exchanged. It is this sodium which is being exchanged. This sodium is being exchanged for calcium and magnesium, and you get a completely new compound which is soluble. Okay, it is soluble, and so that is how you remove. So remember, it is okay. It is the 4 methods that we have read just now. We have read the washing soda process, we have read the lime soda process, we have read ion exchange. Ion exchange is the exchange of ion. It's like a double displacement reaction, but we are exchanging ions for something, for calcium and magnesium. Calgon process is for both temporary and permanent hardness. For Calgon, what is Calgon? The sodium hexametaphosphate, NaPO3 whole 6, which is also written as Na4PO3 whole 6. Sorry, PO3 whole Na4PO3 whole 6. Okay? Yes. Is that understood? So this is what happens. So, chalo. Are you ready for the quiz? Are you guys ready for the quiz? So the topic of water is completely over. Water is done. Hydrogen is done. The only thing which is left out is hydrogen peroxide, which we will do on Monday. So after Monday, what we would discuss is we will start with S block. We will start with S block, that is group 1. Okay. Are you guys ready for the quiz? Is everybody ready for the quiz? Reactions too easy. Okay, reactions are pretty easy. Yes, Vedant, my schedule is pretty fixed. For 11th standard, my session starts at 10:30 in the morning. And for 12th standard, the session starts at 9:30 in the morning. Okay? Chalo. Yeah. Calculations related to estimating the extent of hardness are usually covered in mole concept. If you haven't done it in mole concept, then what I will do is we will take some questions on that on Monday. Okay? Chalo. However, the method is pretty simple. Okay, the method is pretty simple. So let's just start. The first question. The ortho and para hydrogen differ in the number of protons, molecular mass, nature of spin of protons, nature of spin of electrons. What will be the right answer? What will be the right answer? Ortho and para hydrogen differ in number of protons, molecular mass, nature of spin of protons, nature of spin of electrons. Vedant has given the right answer. The first right answer is given by Vedant, then Ankit, Akshat. Okay, the first three people are Vedant, Ankit and Akshat. For every right answer, you can award yourself 100 points. Okay, for every right answer, award yourself 100 points. Every wrong answer, you take away 25 points. Okay, 1/4 deduction is there in JEE mains as well. So for every right answer, award yourself 100 points. And every wrong answer, so for correct, for incorrect, remove 25 points and make a note of it. I will ask you your score at the end of the session. Okay? Clear? I will ask your score at the end of the session. For every right answer, award yourself 100 points. For every wrong answer, subtract 25 points, 1/4 deduction, and make a note. Ek paper rakho, make a note on it. Take a paper and make a note of your marks that you are obtaining. Okay? Chalo. So the first question, I hope people who have answered it correctly have awarded themselves as 100 points, and people who have answered incorrectly have given themselves -25 honestly. Okay? Have you done that? Bataiye in the chat box. Have you done that? Have you awarded this point? I will ask your marks and your name will be reflected in the next session. I will ask your marks and your names will be reflected in the next session. Okay? Chalo. Let's move ahead. Let's take the next question. Ordinary hydrogen at room temperature is a mixture of 75% ortho and 25% para, 25% ortho and 75% para, 50% ortho and 50% para, 99% ortho and 1% para hydrogen. What is the right answer? What is the right answer? Edwin, Vedant, John, Samuel. These guys have given the right answer. The first three names are Edwin, Vedant, John, Samuel. Very good, very nice. So the right answer is A. It is 75% ortho hydrogen and 25% para hydrogen. Okay, 75% ortho hydrogen and 25% para hydrogen. Clear? Very good. Satvik, D is incorrect. Okay, chalo. Okay, people who have gotten this right, please give yourself 100 marks. And people who have gotten this wrong, please give yourself minus 25. Okay, how many questions? How many questions do you want? How many questions do you want? You have 20 questions. Okay, we have 20 questions. Clear? Chalo. If you are not attempting any question, award yourself 0. If you are not attempting any question, award yourself 0. Chalo. Next question is this. Neutrality of the water is due to. Neutrality of water is due to. Neutrality for water is due to pH 7, presence of salts, H plus is equal to OH, concentration of H plus is equal to OH, amphoteric nature. Yes, VSG. With the increase in temperature, the percentage of parahydrogen decreases. The right answer was given by Edwin. The right answer was given by Edwin. The first person to give the right answer was Edwin. The right answer is C. The right answer is C. The right answer is C. Clear? The right answer is C. The neutrality of water is due to H plus, which is equal to OH minus ions. Okay? People who are writing it as D, amphoteric nature, no. Amphoteric nature only tells us that it is capable of giving out H plus and capable of accepting H plus. But neutrality, the meaning of neutrality is the temperature is a specific condition when the H plus ion concentration is equal to the OH minus ion concentration. Room temperature is high. So, chalo. Let's move on to the next question. Let's move on to the next question. The number of H bonds, okay, the number of H bonds formed by water molecule is how H plus is equal to OH minus. That is the definition of neutrality. If H2O dissociates, if the amount of H plus which comes out and the amount of OH minus which comes out is equal, and the amount of H plus and OH minus present in the solution is equal, it is called a neutral solution. Okay. So the right answer, the number of H bonds formed by water molecule is, how many H bonds does water molecule form? How many H bonds does water molecule form? Okay. The right answer is A. The right answer is A. Okay. How many hydrogen bonds does ice forms? Answer will be 4. The number of H bonds formed by water molecule is A. Okay. Chalo. Next question. Which of the following compounds does in which of the following compounds hydrogen exhibits a negative oxidation state? Hydrogen exhibits a negative oxidation state. Hydrogen exhibits a negative oxidation state. Negative oxidation state means the oxidation state of hydrogen will be negative. The right answer, Ranjusha, answer kijiye. Okay. There might be some goof up in the arrangement of questions, but try to answer it. The right answer is, okay, let all of you guys answer these questions. A lot of people are answering HCl. HCl is wrong. HCl is wrong. HCl. Chlorine is more electronegative, so acquires a negative charge, del negative. This is del positive. Electrons are displaced towards chlorine. And so chlorine's oxidation state is -1. Hydrogen's oxidation state is +1. The right answer is A. Lithium hydride. The right answer is A. A hydride will have hydrogen in the negative oxidation state. Why would an element be in negative oxidation state? Because it is connected to an element which is less electronegative than it. Okay? Clear? Chalo. Let's move on to the next question. Hardness of water is due to dissolved impurities of. Hardness of water is due to the dissolved impurities of. Yes, correct, Parth. Hardness of water is due to the dissolved impurities of. What is the right answer? Seventh question. Ankit is wrong. The right answer people are making mistakes in this one. There are mistakes in this one. You have made some mistakes, guys. The right answer is calcium and magnesium salts. The dissolved impurities are calcium and magnesium bicarbonates or calcium and magnesium sulfate or chloride. Okay, the right answer will be calcium magnesium salts. Calcium and magnesium salts. Calcium and magnesium salts can be bicarbonates or can be sulfates or chlorides, and so the hardness of water is because of them. Okay, the right answer will be A. The right answer will be A. Okay, clear? Chalo, let's go on to the next question. In which of the following reaction dihydrogen acts as an oxidizing agent? In which of the following reaction dihydrogen acts as an oxidizing agent? It acts as an oxidizing agent. Okay, in which of these questions dihydrogen acts as an oxidizing agent? You're making a mistake, guys. Sanika, Ranjusha. I don't know whether Sanika has answered the previous question or this question, but I guess it is this question. Sanika has given the right answer. Sanika has given the right answer. Okay. Yeah, what is the meaning of oxidizing agent? What is the meaning of oxidizing agent? An element and substance which oxidizes others by reducing itself. Okay, oxidizes others by reducing itself. Clear? It oxidizes others by reducing itself. Please do remember that oxidizing something else will require you to take electrons from it, and that's the only way you have. Okay, Ranjusha, did you answer? Okay, I thought that you answered the previous question. So Ranjusha has answered this correctly and she has answered this quickest. The right answer is A. You can see that calcium is in 0 oxidation state and it turns into +2 oxidation state. 0 to +2. It is turning in, it is getting oxidized. So it is because hydrogen is behaving as an oxidizing agent, or wherever hydrogen will be in negative oxidation state, that's the reaction where hydrogen is acting as an oxidizing agent. Answer should be A. Answer should be A. Okay, answer should be A. Remember, if in any reaction hydrogen is behaving as an oxidizing agent, it will acquire a negative charge, and if it is behaving as a reducing agent, it will acquire a positive charge. Okay, chalo. Okay, clear? So let's move on to the next question. Which of the following metal does not produce dihydrogen with dilute hydrochloric acid? Dihydrogen is just H2. Okay, chemically, like advanced texts will always use dihydrogen. Okay, you can call it hydrogen, that's not a problem. So which of the metals will not produce dihydrogen gas with dilute hydrochloric acid? Okay, dihydrogen gas with hydrochloric acid. The right answer has been given by, I guess, Heth Patel. Okay, Heth Patel has given the right answer. He's given the right answer the quickest among. He is the quickest among all of you. The right answer is silver. Answer is C. Answer is C. Silver. Answer is C. Silver. Silver lies below hydrogen in the activity series and so is incapable of displacing hydrogen from its salt. Okay, hydrogen from its compounds, from water, from its from HCl, from H2SO4. Ag will not displace it. The right answer is Ag. Ag, Au, platinum, palladium, all of these are present below hydrogen in the activity series. Okay, right answer should be C. Next question is this. Which oxide cannot be reduced by H2? Which oxide cannot be reduced by H2? It's a very interesting question. Not a difficult one though. It's a very interesting question. Okay, which oxide cannot be? Yeah, radioactive can happen. It's not that radioactive elements do not react. However, we do not study radioactive because radioactivity turns out to be a gray area. Okay, sometimes kind of a mystery. The right answer is, I have lost who has answered it first. The oxide which cannot be reduced. The oxide which cannot be reduced. The right answer should be A. Al2O3 cannot be reduced. Aluminium is way higher in the activity series compared to hydrogen. So hydrogen cannot reduce aluminium. Hydrogen can reduce elements which are below it in the activity series. The right answer should be A. The right answer should be A. Okay, right answer should be A. Al2O3 is way higher in the activity series. It will never ever be reduced by H2. Okay, did you answer the quickest? Okay, anybody who's answering after I have given the answer? Okay, A and C should be the answer. Zinc oxide is very close. Okay, so at elevated temperature zinc oxide can be reduced, but Al2O3 can never ever be reduced. Okay, Chinni, you have answered it correctly. No problem. Chalo. Let's move on to the next question. Nascent hydrogen consists of. Nascent hydrogen consists of. Okay, nascent hydrogen consists of, what should be the answer? So how is NIT Rourkela? Mehak, it's a good college, decent. It's a beautiful lawn, beautiful campus. What is nascent? Nascent, you have heard the word in 9th standard, 10th standard. You must have come across the word nascent hydrogen. Again, Edwin has given the right answer the quickest. Edwin has given the right answer quickest. The right answer is hydrogen atoms with excess energy. You take H2 molecule and you use certain energy to break it. You will get hydrogen atoms. Okay, hydrogen atoms, 2 hydrogen atoms, which will be having excess energy. These are known as nascent hydrogen. This is known as nascent hydrogen. The right answer should be D. The right answer should be D. Okay. Sure. Let's move on to the next question. When a sample of hard water is passed through a layer of sodium zeolite is known as permutate. Sodium zeolite is nothing but permutate. It is known as permutate. Which of the following ions will not be present in the sample of water which is obtained? So you take a sample of water, pass it through permutate, through a layer of permutate, and then which ions will not be present in water? Which ions will not be present in water? Okay, I'm not gonna name the person, but I have noted the name of the person. Chalo, very good, Rishikesh. The right answer is given by Sanika. The right answer is given by Sanika. She has given the right answer. She has given the right answer quickest among you guys. The right answer is given by Sanika. The right answer is A. Mg2 plus and Ca2 plus. It is gonna exchange. This functions as cation exchange. Okay, this behaves as cation exchange. Permutate, not permutant. Permutate. We have just discussed this. Cation exchange. So you have sodium zeolite, Na2Al2Si2O8. Okay, it will react with calcium, and so Ca2 plus will replace you. So Ca will be captured by permutate Al2Si2O8, and we will get sodium free in the medium. Okay, so cation will be exchanged. Cation will be captured, sodium will go away. Why shouldn't they be present in the sample? Because they are being exchanged. So the permutate solution, permutate comes, picks the cation, drops its Na plus, so that the sample of water loses those cations which are responsible for causing hardness. Okay, so what will be not present? The ions which are capable of causing hardness, that is magnesium and calcium. Permutate is sodium zeolite. It's a substance which is utilized in treating hard water, and it removes permanent as well as temporary hardness. Okay, clear? Lovely. Okay. चलो, if there is a delay, please refresh at your end यार. होता क्या है ना कि there is internet, okay, internet connection. So internet connection can be slow or fast at your end as well. At my end things are fine. Okay, my end things are fine. So just refresh it once. Okay, so next question. One part of heavy water is present in X parts of ordinary water. Okay, one part of heavy water is present in X parts of ordinary water. One part of heavy water is present in X parts of ordinary water. What is the value of X? What is the value of X? That means what fraction of normal water will be heavy water? What fraction of normal water will be heavy water? Okay, let's see. The the answer was given most the quickest by Chinny. The right answer is C. The right answer is C. The right answer is C. Chinny has given the right answer the quickest. The right answer is C. It is 6,000 parts of water. So 1 by 6,000 parts. That means if you take 1 liter, then 1 by 6,000 part of it will contain hard water. Will be hard water. Will be heavy water. I'm very sorry. Will be heavy water. Heavy water is D2O. So it's very, very small part of ordinary water. The right answer should be C. Okay. Clear? Chalo. Very nice. Let's move on to the next question. Which of the following pairs will not evolve hydrogen gas? Which of the following pairs will not evolve hydrogen gas? Will not evolve hydrogen gas. Look at the combination: iron and H2SO4, copper and HCl, sodium and ethanol, iron and steam. Which of the following pairs will not evolve hydrogen gas? Please answer the question. The right answer has been given by Adish Jain. Adish Jain, he gave the answer the quickest among you guys. The right answer is copper plus HCl. Copper plus HCl will not evolve hydrogen gas. Answer should be B. Answer must be B. Sodium and ethanol will evolve hydrogen gas. Iron and steam will evolve hydrogen gas. Ethanol will react like this: C2H5OH plus sodium. It will give C2H5O minus Na plus half H2. Copper and HCl. Clear? Chalo. What is false about Lane's process? What is false about Lane's process? What is false about Lane's process? The method is used for manufacture of hydrogen. It involves oxidation of iron by steam. It involves reduction of H2O by iron. It involves oxidation of water gas. The right answer, okay. Yes, Shivam. Thank you for being here. The right answer was given by Science World, I guess, fastest. The right answer is D. The right answer is D. It involves the oxidation of water gas. It involves the oxidation of water gas. Okay? Yes, Shivam, I told you. Okay, the right answer is D. It involves the oxidation of water gas. Next question. Which of the following hydrides is generally non-stoichiometric in nature? Which of the following hydrides are generally non-stoichiometric in nature? Non-stoichiometric, we have learned this. The formula will not be in whole numbers. The formula of the molecule, if you take the ratio of the individual species which is present, they are not in whole numbers. Okay. What is the right answer? The right answer has been given by Hit Patel, the fastest. Answer is interstitial hydrides. The answer is interstitial hydrides. Hit has given the answer the fastest. The right answer is interstitial hydrides. Okay, interstitial hydrides. Very good. Okay, answer is interstitial hydrides. Next, dihydrogen gas may be prepared by heating caustic soda on or with. You can say on or with. You want to prepare hydrogen gas. How can you do it? There are so many methods. One of the methods is heating caustic soda with some substances. Which substance can be utilized? I haven't seen who has answered correctly the first. I guess Sanika has answered it correctly first. The right answer is B. The right answer is B. The right answer is B. Zinc. Zinc will form zincate. Zinc plus NaOH. So you will get sodium zincate plus H2. get sodium zincate plus H2. Right? I had told you this earlier that all those metals which are capable of forming amphoteric oxides will also react with NaOH to give hydrogen. The right answer was given by Sanika, yes. Okay. So the right answer is zinc. Okay, the right answer is zinc. Next. Hydrogen can react with the following even in dark. No, zinc is not more reactive than Na. Na is more reactive, but Na does not form amphoteric oxides. Na forms basic oxides. Hydrogen can react with the following even in dark: iodine, chlorine, fluorine, bromine. Thank you, Shivam. Let's see how many have gotten this right. The right answer was, I guess, given by Neeraj Yadav. Neeraj Yadav gave the right answer the quickest. If I'm not wrong, Neeraj Yadav. Yes, Neeraj Yadav has given the right answer the quickest. The right answer is C. Fluorine will react with hydrogen even in dark. Fluorine is the most electronegative and the most reactive halogen. It will react with hydrogen even in dark. Chlorine requires sunlight. Chlorine requires sunlight. Answer is C. Yes, Sanika. Okay. Chlorine requires sunlight. Chalo. Next. Hydrogen has the tendency to gain one electron to acquire helium configuration. In this respect, it resembles alkali, carbon, alkaline, halogens. Alkali, carbon, alkaline, halogens. What is the right answer? Okay, the right answer has already been given. Right answer has been given by Shreya Sahu. Shreya Sahu has given the right answer. The answer is halogens. Tendency to take one electron is a way hydrogen resembles halogens. Halogens also take one electrons to acquire the noble gas configuration. Hydrogen takes one electron to turn into a hydride and to acquire a noble gas configuration. The right answer should be D, halogens. Okay, and this is your homework. This is your homework. Please look at the question. Please look at the question. Nobody would prompt the answer. This is your homework. Please write the correct answer in the comment section and also your location. The first 3 comments that I see, I will name them in the next class. Okay, I'll name them in the next class. So you have 25 ml samples of distilled water, tap water and boiled water respectively, with 1 ml, 13 ml and 5 ml of soap solution to form a permanent lather. The ratio of temporary to permanent hardness. Okay, so answer in comment section. Comment section with your location. Okay, with your location. Yeah, I also teach in the KPY batch. Okay, so Ranjisha, what is your score? 1875. Location means where are you from? Your city. The location means the city from where have you logged in to watch our sessions. Okay. No problem, Chini. So location means city. So please do write this. Next class, I will take the first three comments which I get as for the first three comments which I get as the right answers. I will speak out your names in the next session. Okay. So where are you coming from? If you don't want to say it, that's not a problem. That's not a problem. Just wanted to know from where are you kids are coming from. Like which part of the country are you from? Okay. You could be from different cities. Just to show that to what extent Vedantu is reaching out. Okay. So the right Ranjusha says that she is from she has gotten 1775. Very good, Ranjusha. 1775. Anandan 1050. Aruhi 1150. Okay. Are you do not have to tell me your location right now. You can tell your location in the comment section. Okay. Answer and location. Answer and location. Okay. So I hope you enjoyed today's session. Please join us on Monday. Monday we will discuss hydrogen peroxide and will end the hydrogen topic. A very interesting, very lovely and very scoring one as well. Very simple informations are to be understood, are to be remembered, and most of the things can be inferred. So also please do like, share and subscribe the channel so that it reaches out to more number of students. Okay, don't forget to answer this homework question. Thank you, Sanika. Don't forget to answer the homework question. If you show your work in the homework in the comment section, that will be lovely. If you write your work that how did you arrive at the answer, that will also be lovely. Okay, chalo. Bye bye guys, have a lovely time and keep yourself safe, keep yourself hydrated. Okay, chalo.